Hello, we're going to be making this gearbox here. Have the gear spinning on both sides so the output shaft can also spin. So first we want to make a new part. And this is what the basic SoildWorks screen looks like. The first thing we want to do is a sketch. We can do a top plane sketch. It's important that the first thing that you do is on your origin. It helps out later on. So we did ourselves a rectangle, and also make sure that your units is inches and not metric for this. And something that's very useful is smart dimension. After we drew out the rectangle, we are able to edit the size of it. So for this gearbox here, we have a dimension of 4 and 5.25. From here, we can now add in the holes for our bearing, for our output shaft, our bearing, and our motors. All those holes are going to be in the middle of this gearbox. And we're going to start off with the output shaft, just a circle that is on the center line here, and then another circle here for the middle one, and then for our motor. We can do a smart dimension here to get the distance. For the gearboxes that we're making, if you have a 64 tooth gearbox, so if you have one gear be 14 and then another gear be 50, the distance between center to center is 1.6 every time. 1.605 because we need to have a little bit of tolerance so that the gears aren't super close to each other. And that's the same thing for the output shaft. For the motor. And the distance from the bottom here is going to be 1.5. It's 1.5 because we have to account for the distance, the diameter of the gear that's going to be physically here. It has a diameter of 2.6, and if we have it any shorter than that, it'll be hanging at the edge of that, and we don't want that. So now we can set the diameters of our circles. We can do a smart dimension again. For the output shaft, we use 1 1/8 for that bearing, the hex bearing. So 1.125. For this one here, we use a drill bit that's 7/8. 0.875. And then for the motor one, we use a hole that's 1/2 inch. So now that we have, these are our main holes for our gears. We have a motor here, but for our motor, we still need our motor mounts. So we can do a line from the center point here, and then another line from the center point here. We could do a smart dimension, and for the Falcon sims and mini sims, the distance from the center hole to the mounting holes is 1 inch on either side. And then these are 3/16, but we rounded up to 0.2 for a little bit of tolerance for the motor so that there's a little bit of slop there. But what we can do here is we can select both of these here with control. If we set these to equal, we have to smart dimension only one of these. They will change dimensions with each other. So if we do 0.2 here, they both go down to 0.2. If we were to change this to 0.5, they will both go up to 0.5, but it needs to be 0.2. And now that we have this here, we have the very basic geometry of the gearbox, but we still need to have the holes for our spacers that we mount with. Something that we typically do is a 0.25 from the edge on either side for our holes. So I'm going to do that. Oops. And with this, we will be doing Smart Dimension again. Smart Dimension is one of the best tools of SolidWorks. It is your best friend. So now we can do Smart Dimension here, 0.25, then 0.25 also here. And I believe what we can do here is if we select this one here, this one, and this one, set those to equal, they all get set to 0.25. Now if we select this one, it's not going to let us select that one because it's not the most bottom line. But we can do a Smart Dimension here from that circle to that one, 0.25, and manually enter that in. Again, very repetitive. Here again. And then we already have it set there. So now we can do the same trick that we did with the motors. We draw a circle here, circle here. I think that's not it. Circle here, circle here. Do the same thing. Select, select. With control, if you hold down control, left click on them, you can select those all to equal. And we want these to be a diameter of 0.2 also. These are for the 1032 bolts that we use on site. 0.2. Where's that dimension at? Let's delete that. Let's do a Smart Dimension here. 0.2. And that is the basic geometry. I'm just going to double check this dimension here. That's 0.225, and our dimension is fully defined. It lets us know that every single dimension that we have here has been defined. There's no floating points. Everything is correct. So whenever we get done with this, our sketch is now done. We can now hit exit sketch. And we want to extrude. We want to add material to this 2D sketch. We want to make this 2D sketch into a 3D sketch. So we hit extrude here, and this is here to allow the change the thickness of the material. Be making this a 1/8, so 0.125 inch material. Click on the pieces here, and that allows us to extrude. You can see the extrusion there. If we were to change this to 1 inch, it will go out to 1 inch. If you change this back to 0.125, which is 1/8, brings us to the dimensions that we actually want, and now we can hit check mark. So this part is now done. We can move on to the spacers. So save this file, this part off, and I'm going to name this one here as plate. So file new again. So now here we're going to do another sketch, top plane again, and now we're going to be making the spacers. This is the plexiglass spacer that we place in between the gearboxes to get the gearboxes support. So we're going to do another rectangle here, and then we're going to do Smart Dimension again. We know the height of the gearbox that we just created, so that's 5.0. Let's do that again. Let's remove that. The height is going to be 5.25. That's the height of the physical gearbox. We want to be the full length. And then here, this is going to be the width of the gearbox, and not the width of the gearbox, the width of the spacer, and we use 0.5 for the width of the spacers here. So, and if you middle mouse click, it brings it back to the home page. So now we need to add a line in the center to give us our center line here. And following what we did on the last CAD drawing, it needs to be 0.25 from here. And center from here is 0.25 also. So that's 0.25 here, and do another 0.25 there. And another line up here. Smart Dimension again. on both sides. Oops. Now we need a circle here. Gonna link these two circles together with equal. So clicking on one, then control clicking on the other. Set these to equal. Smart dimension on only one of these. 0.25. And now both of these holes are now dimensioned to the right diameter in the right location. So now we can hit exit sketch. And now we can extrude base here. And for this piece here, for the height of the gearboxes, we had to take into account the thickness of the plates, not the thickness of the plates, the thickness of the gears and the thickness of the bearing. So the gears are typically half an inch each. So a half an inch plus a half an inch for a two-stage gearbox. That's an inch by itself. And then we want to add a little bit of wiggle room for the bearing. So let's add a half of an inch. So we'll be making this part 1.25. Sorry, a quarter of an inch. And that's this part here. This is our space here. So because this part is now done, we can save this part off. Okay, so next what we probably should create is the hex shaft that we'll be working with. Again, we do another sketch, but instead of just doing the sketch, we can also click on this feature here, extrude boss. This gives us a sketch to work with, and then it goes into the extrude feature as soon as the sketch is over. So we hit exit sketch. So we need to make the hex shaft. We use smart dimension here. The hex shaft is here. It's going to be 0.5 inches and the thickness. And as soon as it's done, we hit exit sketch. And now it allows us to extrude. We want this hex shaft to be fairly long. Let's just do a 5-inch hex shaft. Hit that. Because we hit check mark. Now we can save this part here as half inch hex shaft. Let's save this part off now. And the last part that we do need to create is the collars. It's not a good CAD follow for the collars that's public to us. You don't have the spacing exact because they want to give tolerance for teams whenever they're doing it. So the spacing for the collars is never the 0.5. But just for proof of concept, we just want the collars to be the exact space for later on in the video for mating purposes. So that's easier to put the two parts together. So let's do this feature here. Let's make a circle that is let's make a circle that's 0.75 for now. We can always edit this dimension later on. I'm not certain that's going to be the final dimension of that, but we're going to start off with that. Now we can extrude. We can exit sketch now. Extrude, and let's make the thickness of the collar 0.25. Again, we could change these dimensions at any given time if these are wrong. So now we want to put a sketch on top of here. And now we got to put a hex pattern inside of here. So we do a smart dimension, here to here, to 0.5. And look at that, that's pretty good. So we can exit sketch. Now for this piece here, we want to extrude. We want to extrude cut. We don't want to extrude boss. We want to cut. We want to remove material here. So hit extrude cut, and they gave us the right dimension here. We can change dimension. Let's say we only want. Do you want to go fully through here? We go halfway through. 125. it will only cut through half of this. Um, if you don't know the exact dimension of the part and SolidWorks doesn't do it for you, you can just click through all and it'll automatically go through all the piece. Um, but we're just going to do bind, and since we know the dimension of the part, we are going to put 0.25 and just check mark extrude base, and that is a collar. That's a, you could make the hole a little bit bigger, but it's just for a concept. It's not the exact collar, it's just similar dimensions to it. So we can say this part off now. That's a collar. And that is complete for all making of the parts. In the next video, we'll be showing how to put all these parts together and mating the parts and making the gears move together. Hello, now that we have all the parts that we need to create made, we can now start doing the assembly process of this gearbox. In the link down in the description below, I will have all the download links for all the parts from any market VEX that we're going to be using for this gearbox, because we have access, luckily with first, a lot of the vendors give us access to all the CAD files of the motors, the gearboxes, anything that we can buy. They give us access to the CAD files so we can use them in our SolidWorks models. So first we need to file new, and let's make an assembly now. With an assembly, we could pin this here so that this stays, and we can grab all the documents that we want to bring into the drawing. So I'm going to grab all the files here. Open these all up. So what we want to start off with is probably the plate. The plate is probably our base place. This is going to be the origin part. Everything's going to be based off of this for this location wise. But we don't just need one plate. We need a top and a bottom plate. With the plates, now we need spacers. We're going to need one hex shaft, one sim motor, two bearings on either side for the plates, one small hex shaft, 0.37538 hex shaft. These are the bearings for this hex shaft here. This is the gear for the output. Oh, sorry, I lied. This is the gear for the output. They're both 50 tooth gears. This gear there is a gear that goes onto this shaft there. This is the gear for the motor. That's the other gear that goes on that shaft. And I believe that is all the pieces that we need. At any point in time, we can always add more pieces by hitting insert components there. But now, and I have this pinned to keep it visible, so I don't have to keep on clicking this button here. I can unpin that now, and I believe we have all the parts that we need for this assembly. So first, just get some of the stuff out of the way. Okay, so first things first, let's mate some of the spacers to this plate here. With mate, SolidWorks does a pretty good job of kind of understanding what we're looking for whenever we do our mates. So I'm going to click mate to this space here, to this top face of this plate here. I'm going to give us this mate here. This is going to physically try to keep the piece onto the part at all times. Another mate that we could do technically is a parallel mate. If you wanted to keep the faces together, but let's just do this mate here. We can do the parallel mate in a different one. And then we can hit this green check mark here. Now we want to do this face here to here. That's going to lock this piece in so that it's always going to be You can't go up and down with this. Always gonna be side to side with this. So now we need to lock it so that it doesn't go side to side. So now we do a mate of this face here to this face. And now this piece here is fully defined. This piece will no longer move no matter how hard we try. Unless we remove the mates, it will no longer move. So now we can do the same process for this one here. And let's just do a parallel mate just to show that example. So this is going to keep this piece here in parallel with it all times because the up and down motion of it. So now if we do a mate here and here, now we can go up and down with it, but we can't go, oops, sorry, we can't, where'd that piece go? We can't go further, we can't go up and down with this piece, like for the y-axis, or sorry, the z-axis. We can go side to side, we go here, we can go up and down, but we can't go, we can't move it in the y-axis, sorry, z-axis. So now we do this mate here to this mate here. And this is going to lock this piece in so that it can only go up and down. Since we only have this piece parallel to this plate, it has the ability to move up and down. So now we can add this mate here to keep it from moving. And now this piece won't now no longer move like this piece here, no matter how hard we try. We could do this plate last. So let's start off with the motor. So on the motor, we can do a tangent mate. We click in the inner circle of that, we click on the outer circle of this, it gets mated together. Click on this face here. Where did I think? And then we click on here. Now this will have the ability to later on rotate. This piece will be able to rotate around its shaft. Let's hope it does. So now we can put this motor onto the gearbox. Oops. So we hit mate, click there, click here. So now we got to get the holes in here to mate with the holes that we made for the mounting of the gearbox. So we got one of them. So what we can do is we can hide this piece here. So we can grab this and everything in the hole there. Once we hide it, where did that piece go? Wait, we can show the plate again to mate here. Allow that mate to happen so that this piece would no longer move. And this piece is now fully defined. The gear is not. The gear can fully rotate on it since we did not constrict it to not be able to fully rotate, which is what we want. We want this gear to be able to rotate with the rest of it. But the motor would not rotate. So now we need to add, let's add the collars for this piece here. Add the collars, put them in the inside here. Yes, we like that mate. So now we want to grab this inner piece here. Click here. So now that this will allow, so this won't move. Only the bearing will rotate, which a bearing is supposed to rotate. We allow that. We don't want to fully define this, otherwise the gears won't move. So now we can grab this piece here, mate it with here, and that's good. And now we can drag this up even more. And we can grab a face. Let's grab that face there. We can mate that face with this face here, as if we're doing it like on the actual, like we're assembling the gearbox. That's how we do it. I'm making this just as I would make the gearbox in person. That's how I'm pretty much mating all the pieces together. So with the 14 tooth gear here, we need a 50 to satisfy the 64 tooth rule, so we can keep the distances similar. So now we're going to grab this piece here. We're going to mate on that edge there. But first, let's make this piece parallel to the part. So click here, make it parallel, and that's what we want. So you can drag this part, bring it up, so that's kind of in the right plane. Make it a little bit easier to mate. But now you can click on this face here, and then click on the face that's kind of similar to there. Yes, we agree with that. So now we want to click on that face, and you want to find the face that's gonna, if you're putting this gear on there, the face that's correct. So this face here is correct. Now that piece is going to be defined to only allow this to go up and down. It will also rotate with the piece. And as we rotate this, the physical hex shaft also rotates. So now we can mate this piece here to that bushing there. So now whenever we rotate this, the hex shaft also rotates. So now we got to repeat the same process onto the 14-tooth gear that will be used for that output shaft later on. So let's clear that section. Let's first make it parallel. Let's grab that front face, parallel, select parallel, make it parallel to this gear here. That's fine. Where did that gear go? Haha, there goes that gear. So now we do the same process. Made it with that face there. So now we're going to grab this face there. Made it with that face. Oh, wait. Let's not do one that's in parallel. Let's grab that one there and that one. Mate. Grab that face there, that face there. Make the part not be able to move in the axis that we want to control. Mate that with that. So now this gear rotates, the whole thing rotates like how we expect on a normal gearbox. Whenever we rotate this, we expect the shaft to rotate the same rate. So now that that's done, let's add the final bearings, which are here. So we got this face here on the bearing, made it to the outer ring here. And again, just how we assemble it at the build space. Click here, made it to that flange there, and we don't care that this rotates. We allow that. Perfectly fine with that. So now we can add the same process that we had for here. We can mate the gearbox over the output shaft to there. Let's do a parallel mate with that one. Where's the little check mark? Checkbox. Parallel. Okay, I don't see the little checkbox. Okay, so that's now parallel. Let's grab a mate here to the here. Let's grab this mate so that this is up against the hex shaft. There's something cool that we can do is that this is almost correct. It's just that the height's not correct. We can do a distance mate. We can define the distance that this hex shaft is going to be from out here. We have to take account from the 0.25 collar and probably about the 32nd of an inch spacing there. So let's just do 0.75 to make it simple on this. We click here, there, and we do distance. We can define the distance. And now for the distance, let's do 0.75. And that's good. So now this will stay 0.75 distance. It still rotates, but stays 0.75 distance there. And like how we would do in there, and look what I did. I forgot my collars. So now what am I going to do? I'm going to import my collars. So now I'm going to hit checkmark for this mate, import components, collar, and lock this. So let's grab our two collars here. Checkmark. So now we're going to do mate again. Make the collars parallel first to begin with. We don't have to make it parallel. It's just something I'm just kind of habit to. It just makes it a little bit easier on me. Drag it closer. Make this side here to that side there. Grab that side to that side. And a lot of the movement I'm doing with my mouse, I'm using the middle mouse button to rotate, and then the scroll wheel to zoom in and out. It's very useful for 3D, but when it comes to 2D, this is really hard to get around. Because if you rotate, you're rotating a 2D object. You have to bring it back. You have to click this button here to bring it back to the front face. Let's say that if you want to go to that. But with 3D, SolidWorks is really good about that. So now we can do a mate here to here. We want to make sure that these holes line up. In real life, whenever we are building this, we want these holes to line up here so that we can always take the motor on and off without taking the whole gearbox apart. That's the goal. So we do the mate there, mate here, and now this part here is fully defined. No matter how hard we try, we cannot move that part. So now we got to add this gear here. Well, let's hide this piece here for now because we put that piece in too early. Let's grab this gear here. Let's first do a parallel mate so that the piece stays parallel. That's good. Bring it up, drag it. So now we can grab this piece here, mate it to there, and now we can mate this piece here to there. Voila. Now we can mate this face here to this face with a slight different distance. We could do like a 0.125 distance. So that piece is not rubbing up against there exactly. Yeah, ideally, we would try to put like a spacer there or put some grease there so that there's less friction. But that would do for now. So now we can do the mating for the actual gears itself. Hit the check mark. Let's do this gear here first. But first, let's make it look correct. Make sure that this is just for aesthetics. This has nothing to do with the actual drawing. This is so that you can see it rotate. So you can physically see that your spacing is right. But we can grab that gear there, grab that gear there, and these gears are aligned, or as aligned as we can see with our physical eye. So now we do a mate. We do a mechanical mate, mechanical mate, and if we do gear, we can select this tooth on the gear, and then select this tooth on the gear, and it gives us the diameter of everything, and it does a ratio for us here, and we hit check mark, and now these two gears are linked together. So we need to repeat the same process for this gear. Click that gear there, click that gear there. Oops, sorry, gear. It's same process, gear, check mark. So now if we hit the check mark here, we rotate this here, the other gears rotate. We rotate that, the other gears rotate. Since we're gearing down, it takes a lot more resolutions to make this move. But if you move it on this side, the motor's gonna move really fast. Same thing in person. So now that we are done with that, we can now show our part again. Show component. So we can add this collar in now. I really don't like where that's at right now. We can just move that. And we can undo, do that mate process again since the part was upside down. Grab this piece here, and the part is still upside down. We just change the direction with that button there. That just flips the alignment, just pretty much flipping the direction of the part. So we zoom in, grab that face there, mates it with that face there, and that's done. And now we grab our final bearing with this bearing here. bearing hole there. Oops. Does that look correct? Yes, that looks correct. Drag that out. Oops, that does not look correct. Let's undo that. Control Z is a shortcut for undo if you don't know that already. Works on Windows stuff all over the place. Let's do that mate again. Flip direction. Drag that out. Oops. Drag that out. Hit mate. Drag that out some more. Mate. Oh my goodness. No, mate. Mate. This piece here to here. Just grab that corner here. Let's mate it with that one there. Let's grab that one. Mate to that one. So now whenever that rotates, they all rotate together. And finally, last part, we need to mate this collar to here. Do a parallel mate for that first. We grab this piece here, mate it to that. Looks good. Grab that, mate it to that one. Looks good. Grab that, mate it to that one. And voila, we have a finished gearbox. If you really care about the dimensions and how I got them, you can talk to me, or I can make another video about it if enough people ask about it. And I will have the link in the description of where to get all these pieces at. That's provided by Anywork and Vex. Those are the two resources I use for the gears and motors. Thank you for watching. Hopefully you learned a little bit about SoildWorks.